Project Cognit focuses on the cutting-edge world of the cognitive cloud-edge continuum and how it's reshaping the future of computing. This EU-funded project's transformative approach is set to revolutionize edge application management and create a vibrant ecosystem of innovation across Europe's cloud and edge landscapes. Together with Tomasz Korniluk, project manager of Cognit, and my guest for this episode, we're going to discuss how the project is tackling major challenges like performance, resilience, security, and data sovereignty by introducing a new AI-driven serverless framework. So, Tomasz, can you explain the main objectives of the project and how it aims to revolutionize edge application management?
I think we could aim three main objectives of the Cognit project. First is introducing new function as a service paradigm for the edge applications based on the code offloading. And this objective is really close to me because of my before the experience as embedded software developer, and it basically allows to extend constrained resource devices with extra resources, and for example, it allows for integrate AI models in that kind of devices. Second objective is to create a framework for managing highly distributed resources across the cloud edge continuum, but also connect already existed data processing resources from cloud providers. This kind of approach allows us for fulfilling all needs of all different applications. And third one, I think it could be making data processing optimized and somehow self-adaptive because of powering some tasks or framework with AI, so it could be flexible to the application demands, behavior, and also to energy efficiency heuristics.
And you think that by following those three goals, your project will revolutionize, let's say, edge application management?
Yes, I think so, because it is a big problem with in-edge IoT devices that there is a lack of resources, and we could extend these resources with these which are on the edge, and it opens new doors for new technological solutions.
Can you explain the main challenges that need to be addressed when building an effective platform for the cognitive cloud edge continuum?
There are plenty of the challenges, but I think one of the primary challenges is that to make accurate assumption which lead us to the well-suited requirements to the framework. And in the Cognit project, we are reaching that by cooperating with many of the use cases. And for example, one of the use cases is a smart city use case, which is focusing on the controlling traffic lights in that manner to give buses priority to go through the traffics more easily. And in this use case, the most important factors are latency and short response time. For example, in the next use case, in energy use case, it's common situation that there are many of the devices in range of the same geographical area. So the most important factor is that for the platform that it can handle that kind of situation where there are many concurrent requests which are different in workload specific. For example, in wildfire detection, the most important features are ability to handle sudden peak of requests, and the best option is to execute these requests on the GPUs.
I would assume that AI, automation, etc., would assist in solving, let's say, these issues. So what roles would you say AI, automation, portability play in creating disaggregated architecture for managing resources and workloads across the cloud edge continuum?
I think AI plays one of the primary roles here. Because with AI, we could reach a high level of the automatization. Because using AI models, we could decide how and where across the cloud edge continuum execute specific workloads. Using AI to doing that task, we could do it really in automated manner and without involving humans. Regarding to the portability, I think that portability is really important because of the specific of the highly distributed resources. Because in DNA of this solution, there is assumption that it could be implemented on many different types of hardware. Platform which are going to manage that has to be able to be implemented on these different kind of the hardware, but also it has to get ability for allowing connecting edge nodes implemented in different hardware and be on top of that and control everything.
Hence the portability necessity. It makes total sense. But one of the aims of the project is also to create a new function as a service paradigm for edge application management. How does this differ from traditional cloud services, and what advantages does it bring to edge computing?
New function as a service paradigm for edge applications based on code offloading differ from traditional cloud services because of its specific and its aim usage in the constrained resource devices. Because, for example, in the energy meter, we are developing it under C language. And there were not enough resources to run a Python interpreter. But if we use Cognit to extend it with that resources, we could write Python code and keep it in flash memory, because these constrained resources most often are connected with lack of RAM memory. And if we could keep Python code as string with the flash memory, in the flash memory, we could write Python code where it wasn't possible before. So this is one of the advantages and different approaches than traditional cloud services. I think also this powering with AI and deciding where and how execute workloads is different approach, and I think this will be next generation technology in terms of the cloud technologies.
Everything that you have described also entails the notion of large data usage and data accessibility. And I know that Cognit, correct me if I'm wrong, but I think that Cognit aims to enable secure and portable access to data processing environments. How does the project address security and data sovereignty and energy efficiency concerns, especially for sensitive edge applications?
So in sensitive applications, security is always a really important requirement. Platform framework addressed this requirement by using all needed encryption mechanism, and also it brings AI to work on it, because AI will be trained to detect anomalies in the behavior of the framework.
Okay.
It could show us where are vector of attacks, and it will be easier to protect these specific features.
The project draws inspiration from the SovereignEdge.eu initiative. Can you tell us more about how this initiative shapes the project's goals?
Cognit project is fully aligned with assumption of the Sovereign Edge initiative, because it is all about creating next generation technologies which could give us as Europe data sovereignty and independency from the hyperscalers. I think in today's world, data sovereignty and owning our own data it means money, because we could benefit from that. And nowadays we are trying to make independence from the hyperscalers, and also Sovereign Edge initiative are focusing on creating highly distributed resources in form of edge nodes, and main goal of Project Cognit is to create framework for managing these kind of resources. So that's why I think it's fully aligned with that, and I think it's important to get this independency, because as I read a couple days ago, there were researches about where is the best place to live and the best political system to live, and Europe won that. And if we want to keep the position of leader in that matter, we have to be independent and build a set of open source technologies. For example, if we get a set of that technologies, we could find really good synergies. For example, I work in the Phoenix Systems company, and we are developing our own operating system for edge IoT devices. So Cognit framework is also open source. So I see a lot of synergies and opportunities across using both of these technologies.
Yes, I've seen many projects opting for open source technologies nowadays. So looking beyond the formal end of the project, what long-term impact do you foresee?
Maybe I present here energy use case point of view. I think after project, because we are ending at TRL 5, so it has to develop, developing processes has to be continued to gain TRL 8 or 9, and in terms, for example, for energy communities, where there are needs for keeping not only using data, but have it, as I said before, because we could benefit from that we are owning our data. We could power, for example, energy meters with AI models and trying to optimize usage of locally produced green energy, and in the same point minimize usage of energy from power grid and transform to the distributed model from centralized model of energy production.
Sounds like a good plan. Thank you very much, Tomasz, for this interesting conversation.
Thank you very much. That was a pleasure.
And thank you for listening. For more insights on EU-funded energy projects, please subscribe to our podcast.